Q&A. Both of our talks are student talks, great students who've done fantastic work, which is going to top shelf conferences. Lindsay will be speaking second. Megh Marathe is starting off. Megh is a third year PhD student. This is his work on semi-automated coding for qualitative research, but besides doing work on machine learning and qualitative research, also has been doing a lot of work on disability and the portrayal of disability in science and technology studies. So, having said that, we'll get started.
Thank you. So, hi everyone, my name is Megh, as Jayajit said, and I'm here to present joint work with Kentaro Toyama. And this was part of my pre-candidacy. It's going to be presented at CHI, and we'd like to thank Salita, Megh, Jaren Budak, and Jayajit for feedback on our paper, which really helped us, I think, push it through. So, qualitative research has a rich tradition originating in the humanities and social sciences. It covers a range of approaches such as ethnography, phenomenology, action research, and so on, and employs a range of methods, most significantly interviews and participant observation, document analysis, and so on. What this means is that qualitative researchers spend a lot of their time dealing with large amounts of textual data, which can be both structured and unstructured. And as a first step of their analysis, they typically go through this process called coding, which involves assigning, Okay. It involves assigning short labels or codes to chunks of text.
I think the computer froze and I was doing all at once.
Sorry. Yes. 2 chunks of text in the first step of analysis, which is called first pass coding. And this is done to allow researchers to categorize their data, to surface patterns in them, and relate codes to each other. And researchers really cherish coding because it allows them to build an understanding of their data and to sort of see what patterns are emerging and build a nuanced understanding, which is the goal of analysis. However, at the same time, coding, good coding, is both a science and an art, and it requires a lot of training and experience for researchers to be considered good at it. At the same time, typically a single semi-structured interview corresponds to over 13 pages of typed text, so we are dealing with large amounts of data, and it requires several hours to code a single interview. So what this means is that over time and historically, this has led to the development of a category of specialized software called qualitative data analysis tools, or QDA tools, such as NVivo, Atlas TI, QDA Miner, Deduce, and so on, specifically dedicated to helping researchers manage the problems of organization, retrieval, and coding. However, most of these tools are focused on providing analytical support in terms of computational support after coding has been done. And in practice, what happens is that the advanced functionality is typically too complicated or hidden away for researchers to use, which means that over 20 years, people have found that people use these softwares mainly as electronic filing cabinets. So, which means that they use it for organizational purposes, but not so much for analysis itself. However, so what this means is that, in addition, the coding process is not properly supported because the focus is on analysis. Whereas the field of natural language processing has as its main goal the categorization and analysis of textual data. So we find that there is promise for NLP to help in the process of speeding up the process of coding. So we are not obviously the first people to propose this, and there is already research going on in 2 main areas in natural language processing. The first set of research looks at building interfaces that allow data exploration, especially for large-scale data sets like tweets and so on. And the second body of research looks at enabling a particular kind of qualitative inference technique called content analysis, which basically is, so if you're studying emojis, then go look for the number of times emojis occur in the text and so on. So this is more intended to support quantitative claims. What these bodies of literature have found is that researchers are indeed able to exploit the interactivity that these interfaces provide, but they are frustrated by the black box nature of these algorithms because they are provided recommendations with no explanation. And frustrating. Further, I find that this literature is typically focused on enabling new forms of analysis without looking at how people are currently using it. And so, what we find is that there is definitely promise in applying NLP techniques, as these studies are finding, but there are not enough user studies that identify opportunities for computational assistance in current use. And so we risk building tools that may not meet user needs. Therefore, we start our paper with two research questions. First is to examine how do qualitative researchers currently code, because studying the status quo helps us understand the needs and desires but also existing practices. And secondly, could first pass coding be partially automated, and should it be? And if so, then how far can the simplest NLP techniques take us? So we use a two-phase mixed methods research design with one phase for every research question. In the first phase, bless you. In the first phase, we conducted a user study with 15 trained qualitative researchers in 2 rounds. In the first round, we recruited 5 participants for 3-hour-long contextual inquiry sessions where we interviewed them but also observed them code a set of 5 transcripts that we gave. So all researchers coded the same 5 transcripts. And in the second round, which was in parallel with analysis, we recruited additional 10 participants to both validate and verify the applicability of our findings until theoretical saturation was reached. And when conducting analysis, our focus was on understanding what users' current practices are, what they feel about the currently available QDA tools that they use, and how open they are to the concept of automation. So I'm going to present, our findings basically fall into 3 main categories, and I'm not going to cover all of them because it's a lot of stuff, but so I invite you to read our paper for that. But in 3 main categories. So first is, despite the relatively small sample size, we found considerable disciplinary variation amongst our sample. And what this means is that, most simply, for example, the discipline affiliation of HCI, people prefer that the software be relatively lightweight and built for collaboration from ground up. And so they use things like Google Docs and Google Sheets and so on. Whereas the more social scientist-oriented people tended to use established commercial software such as NVivo, Atlas, and so on. But beyond the sort of surface level thing, we found that there is also a but there is a difference in what each discipline considers the whole purpose or goal of coding itself. So for the social scientists, there is often a correlation or a direct correspondence between a set of codes and, say, a section of the final paper that they write. Whereas for an anthropologist or an ethnographer, a code, like the process of coding, is simply a jumping off point for writing ethnographic notes or ethnographic field notes. And so they would never actually report how many codes they used or what kinds of codes they developed and so on in their final paper. So I thought this was pretty interesting. In terms of QDA interface design, so what the interface for a qualitative data analysis software should look like, we found that researchers spend a lot of their initial data analysis time and effort in developing a code book, which is essentially a list of codes. So as I said before, codes are short phrases that are applied to chunks of text. And this can be as simple as just a listing which contains the names of the codes, but it can also be more complicated, like spreadsheets which contain names of codes, but their definitions, usage notes with positive and negative examples, and so on. So fairly complicated stuff. But none of the commercially available QDA tools support codebook creation, piloting, and so on. Because while developing the codebook, researchers start with an initial codebook which they then apply to a set of data in order to be able to refine it and sort of create new codes or merge existing codes as they come across patterns in the data. What this means, for example, is one of our participants, Jane, says that she spent a lot of time developing this beautiful codebook which was categorized, but then Atlas TI shows it as a single list organized alphabetically, and so did not retain her mental model at all. So we recommend, as our first thing, is to allow users to pilot, group, and visualize codes during the codebook development process. Second is that throughout the coding process for a particular project, researchers very consciously decide the length of the span of text that they annotate with codes. And this is called a unit of analysis. It tends to, throughout a project, state either a sentence or a paragraph or a conversational turn, and sometimes phrases. But QDA tools do not recognize this. What this means is that whenever you're annotating a piece of text, you have to select the start and end very precisely. And it forces you to do that each time. So if you think about it, if an individual user is doing it, essentially it means a waste of time or a repetitive burden. But in team-based research, it becomes even more serious than that. Because you're trying to have multiple people code the same set of data fairly uniformly. So it involves establishing what is called inter-rater reliability. And again, one of our participants was doing this with a colleague, and there was this large chunk of text where she coded every utterance with some code X. But he coded the whole thing with the same code X. But the QDA tool does not recognize units of analysis, and so it says that there was nothing similar in these two things of coding, whereas essentially they were doing the same thing. What this means is that the colleague had to go back in and manually recode the whole thing to conform to the pre-decided unit of analysis. And so we recommend that QDA tools should ask users for their preferred unit of analysis, and if they detect that it's making a mistake, it should auto-suggest the closest matching unit. In terms of algorithm design, we find that qualitative researchers are fairly open to the possibility of automated recommendations, but they are very hesitant at this point because they have tried using some of this functionality and it does not work. So for example, during our observation, one of our participants, Rachel, created a code called honor, and she asked NVivo to auto-suggest places where she could apply it. NVivo does this using synonyms, and she created the code ethics. And she meant moral codes of conduct, but NVivo showed snippets of text which contained the word honor to mean like respect, which had nothing to do with her code ethics. And so she was like, I wish I knew what dictionary they were using, like what are the synonyms they are using to suggest these things to me, can I change them? Because then I would consider using something like this. And so we recommend that qualitative data analysis tools should make their recommendations transparent, and that they should show the criteria behind their recommendations and ideally allow users to change them. This would make people adopt them more. Third, when it comes to what parts to automate, we found that qualitative researchers care a lot about the code book that they develop because, as I said before, it involves a lot of analytical effort to develop a really solid code book. However, once such a code book is developed and a set of data is coded to pilot that code book, people find that coding the rest of the data with that code book is essentially repetitive and very dull because there is little analytical effort and almost no new insights. So that is where researchers would really appreciate the automation. And so we recommend that QDA tools should use the fully developed code book along with the pilot coded data as training to code the rest of the unseen data. So to summarize our findings, we find that researchers follow several practices that are well suited to automation. Researchers also desire automation, but after the code book has been developed and when applying it to unseen data. And finally, they require transparency in automated recommendations. So based on these findings from phase 1, we conducted the second phase where we tried 3 very simple NLP techniques to understand how far they can go in achieving these desired recommendations. So all of these techniques basically take as input uncoded transcripts, the fully developed code book, and some high-level instructions for each code. And they produce as a result coded transcripts, which we then evaluate against the data that participants coded during observation sessions. And then we report our results in terms of precision, recall, but also inter-rater reliability, which tells us how much they agree with the human coder. So we have 3 techniques. The first one is the bare minimum NLP technique, which is simple keywords. What it does is if you have a keyword code-like definition of research, it takes all non-stop word keywords, so things like definition and research, and matches them to each chunk of text. And if the cosine similarity score exceeds a certain threshold, that code is assigned to that text. The second one improves this technique. It is called augmented keyword because it allows users to specify additional keywords like synonyms or spelling variants and things like that to account for, people use different terms to describe the same thing, or sometimes it's misspelled and so on. So this, for example, in define definition of research, I would add things like define or inquiry and so on to augment my results. And finally, the most complicated technique we try is search style querying, drawing sort of from the popularity of Google-like search engines, which allow users to specify one Boolean query for every code in the code book. And so, for example, if I was talking about definition of research, I could do something like define or definition and inquiry or research. And this query would be matched against every chunk of text. And if it exceeds a certain threshold, again, we assign that text. So just to remind you, this produces a coded transcript that we then compare with the data that participants coded in their observation session. So as expected, the simple keyword technique performs very poorly, and that's because it's a very unsophisticated technique, and the only place it does well is in the in vivo codes, because they are created using language present in the interview transcript. So that's where it achieves like some semblance of precision and recall, but overall it does very poorly. The augmented keyword technique more than doubles the recall of the simple keyword technique when it comes to more descriptive or meta codes, which are not using language present in the transcript but saying something about it. So that's where things like synonyms or spelling variations really help. So if you can see, the recall is doubled. And surprisingly, the iterator reliability that the augmented keyword technique achieves is on par with what human coders achieve after the first round of iterator reliability. And the third, sort of the most sophisticated search style technique actually shows a dramatic improvement in precision and recall, but also in iterator reliability, achieving a precision of 88%, recall of 83%, and iterator reliability that would be considered on par with what human raters typically end with when they say, all right, we have achieved iterator reliability. And the reason for this is that the first two techniques suffer a lot from overprediction because they don't allow for negative indicators. So people create a lot of parallel code. So things like definition of art research versus definition of science research. And here in this case, if the chunk of text contains art, it's a pretty clear indication that it's not a definition of science research. But these techniques are not able to exploit that, whereas the search technique is able to exploit. And the second thing is that in the first two techniques, they consider every keyword to be equally weighted. So for example, if you have a project about art research and the code is definition of art research, then definition is clearly the most important word there. And art research don't matter so much because the whole project is going to mention art research. Whereas the search style technique, you're able to customize it more, and so that is why we think it does better. In fact, we examined the places where the search style technique's predictions don't match human coders' predictions, and we found that in over half the cases, this was the result of human error, which means that there may be potential to use this for people to detect omissions in their own coding. And we think that, question.
I forgot this, what's the iterator reliability is based on what is at the sentence level, is what's the...
It depends. So it depends on the unit of analysis that you're using. So we used conversational unit of analysis. But basically it's sort of comparing two people's coding and how much they agree. It's a statistic.
Right. So then you still have the same problem of two people in chunks of...
Right. Right. So we find that these results show high potential given that we are using extremely basic NLP techniques but still achieving significant results. Of course, our work is not without its limitations. So our participants were mainly PhD students of age 35 and under, and we should try seeing if our results generalize to more senior researchers. Second, obviously we had an artificial scenario where we provided transcripts to people and asked them to code. So it would be good to test this on researchers' own data because that's where they know the most. And finally, we are using very, very simple NLP techniques, so we should definitely experiment with more sophisticated ones that are available today. And given that we are testing an assistive tool, using just quantitative measures to report results doesn't make sense. So therefore, future work should definitely build an interface and look at usability also and real-world performance. So to summarize, we conducted a user study where we observed researchers code and interviewed them about the practice of coding. We found that researchers follow several practices that are well suited to automation, but they desire this automation after having developed the code book when the automation involves actually coding. And finally, the automated recommendations must be transparent and free of technical jargon, ideally allowing users to edit them. Finally, we experimented using 3 very simple NLP techniques which achieved significant precision recall and iterator reliability, so this shows potential for using this in future work. Thank you. Also, since this is going to be presented at CHI, I would love any feedback.
I have a question.
Yeah.
Did you use any automated assistance in the analysis of your own interview data? Never mind then.
I'm old-fashioned that way.
So there's one presentation item I would point out is that I think if you can go back a few slides. Yeah, this next slide. At this slide, you could actually give an example, and it would be much more evocative rather than trying to explain. So what is simple keyword?
Right.
Example.
I'll just give consistent feedback to that. You might try to leave 1 or 2 examples throughout the whole talk. One thing to keep in mind is that at CHI, I don't know when you're presenting, but soon you're in a long series of presentations, it's a big room, there's people way in the back who can't see your slides. And so examples will help them latch on to things when this is just not in rules. Assume like half of them can't even see
Okay.
slides like that.
Okay. It's my first time at CHI.
Yeah. So it's potentially big rooms, organized in unusual ways. You can't control it, so you want to not rely on detailed content in the slide frontal. And assume people are tired, distracted.
It is enough.
Which is nothing to do with you.
Yeah. Thank you.
Do you have any future?
Sorry.
Do you have any future work in this area that you are already working on?
So we are trying to work with researchers' own data, but the problem there is that it's in our paper is most of this is in proprietary data formats which are not easy to extract for computation processing outside, say, Atlas or NVIDIA. So if I want to run my own code, then I have to manually, which is what I did for this project, I manually sit and replicated people's coding on plain text files. That is the stumbling block, but we are trying because there is this person in anthropology actually who has a partnership with Atlas DI. So we are trying to see if we can do something there.
In your user testing of the prototypes, were any of the researchers concerned about, I'm trying to think of how to word this. So for me, like the process of coding interviews is so integral to generating analysis, and it's less about the actual process of coding, which does get monotonous, but it helps me sort of formulate what the emerging themes are and what it helps me lay out the narrative. So were any researchers concerned that they would lose that aspect by introducing automation, or at least in part?
Yeah, so actually that was a big reason why people said they would only choose automation after having developed a solid code, by which time they would have gotten some sense of the data.
Gotcha.
And also nobody said they would blindly trust these results. They would still want to go through it. And a concern that came up is that for experienced researchers this is fine because they know that these are suggestions. But for newbies who are just learning to code, this could mislead them into thinking that this is what coding is. So yeah, it's definitely a valid concern. Yeah.
It could be something that vary by people, but if could you go go to the next slide? Because like here there's a lot of, I think you mentioned 4 different points. I wish you could like highlight certain numbers that are relevant to what you're talking at the moment, so that they can see what they should be able to. I mean, they should see at the moment. So, because you have a clear connection, but like people in the audience will not have that. So highlighting certain part of the table when you say something, that would be great to tell where they should look at. So
That makes sense.
Yeah, I had the same thought about it. That
Too
this
many
table
numbers.
is sort of like, okay, what is this?
It's also not clear what the rows mean.
Yeah.
Right. I think I might just simplify this drastically. Very good.
So on the point that you made about using advanced NLP techniques, that goes to the point which came here as well. is it, are you saying use more contextual understanding of coding based on broader corpora of material which explains what things mean, or I mean, you're saying like next step is look on the web
Right.
for what this term could mean in this context, or because I was like a little bit confused about the point you made about there's stuff that's owned by Atlas, but that's not what that's not the core of what you're adding as value here.
Yeah, absolutely.
Yeah.
So actually there I just meant that is like a major roadblock because we can't get data out of Atlas. So we can't even experiment with NLP techniques, but what I would suggest, for example, for more advanced techniques, is they typically require a lot more training data. But what we found is people, when they are using codes, they look at past literature or some theories from which they are drawing these codes, or just existing sort of literature out there. And so one way could be to use that as some of the training data, so as to give some larger context to the study. Because otherwise what happens is NLP techniques tend to not have much context, and they are developed on, even today, a lot on news corpora and things like that, which are far too generic for something as specific as qualitative research.
Okay.
So I would suggest like adding some academic papers or whatever background literature there is to some of the training.
So related to that is that when you were mentioning the initial point about these files, like NVO files being basically just out there in your cabinet somewhere, this is totally true for me. And one of the problems which one deals with is after coding, there's this overwhelming moment of there's all this stuff and there's no way to relate things to each other easily.
Right.
And that's something that this work does not deal with at all, and maybe you don't want to go there at all. But it might be something to think of as almost like hoping that would be something in the future work. You have all these things you coded with, how do they relate to each other, with the frequency of occurrence or the likelihood of one. I mean, right now the software will make you say that this relates to this as what, and then even as you're doing that, you're like, what does it really mean? Like, I've finished making this line between them.
True. So actually some of the data exploration literature looks at that, but yeah, that was not our focus. Because they are, for example, looking at millions of tweets, right? And so one thing they try to show people is visualizations showing automatically which things are related.
Yeah,
Okay.
yeah, but they don't deal with the big text problem. Yeah.
Other questions? Okay.
Excellent.
Thank you.